Okay. Can everyone hear me? Unfortunately, I talk very loud, and it's early in the morning. So, first of all, thank you very much for coming out. My name is Pat Fetty. I'm joined here on stage by Alan Stewart and Damian Flynn, who is one of our premier TAP customers, and you're going to hear from both of these folks later. I'm based out of Redmond, Washington, and I work in what we call the Partner and Customer Ecosystem Group. And so our group are the people that run the beta programs, or a TAP, which is Technology Adoption Program. First of all, how many of you have ever participated in a TAP with Microsoft? Look at that. About half the room. So you understand the concept. So what we're going to do today is we're going to talk about a lot of the lessons learned that we found, particularly in the cloud space, throughout the TAP. We'll give you some details as to how many customers, what they're doing today, the technologies that we're covering, and so forth. But realistically, what we really want to do is give you real-world examples of what our customers are going through as they get Server 2012, which I'm sure by this point you realize there are a ton of new scenarios and features that are enabled in this release. So hopefully as you walk away from this, you'll have a good understanding of the challenges that our customers are facing, which are really design decisions. When you release an operating system of this magnitude, and I can tell you, I've been at the company 15 years, and all of that time has been in the Windows division, and this is by far the biggest release of Windows that I've ever seen. Windows 2000 was really the last big one. And so there are a lot of challenges that our customers faced, and we're going to show you some of those. We're also going to show you a demo today of a scenario that we enabled within the TAP that's actually very interesting. So like I said, we'll go over the TAP. We'll go over some of the technologies. We don't want to bore you. We're not going to dive in deep into the details of some of these because you've been at other sessions this week and understand a lot of these things. And plus, we have the booths where you can talk to other engineers. But we're going to talk about something that we called the customer zero work. And again, this is unprecedented. What we've done here is that essentially we took a lot of these complex scenarios and built them in our labs in Redmond from top to bottom before any customer ever saw any of this code. And there are lots of good reasons why we did that, is so that we can understand the complexities before we give code to our customers. So the TAP this time around, if you, like as most of you have participated here, you realize that essentially at beta we just give you some software and some documents and we say, okay, go ahead and test it and give us some feedback. But we've done things very differently this time. We'll explain that to you as well. And then we'll also bring Damian up, who is like I said, a real customer, and he's going to tell you about his experience and some of the things that they've gone through in testing Server 2012. And then Alan's going to go into some more details around specific design areas around storage and networking. These are probably the two most complex scenarios within the cloud space, so there are lots of important decisions that need to be made, and Alan's going to go into the details of that. So most of you already know what a TAP is, so this time around we did approach things differently. Very differently, in fact. So again, I have a lot of history in the Windows division, and I can tell you going way back to Windows 2000, the way we designed Windows was essentially within Redmond. So we have very smart people, very bright people at Redmond who would come up with ideas and scenarios. We would then develop on those, do some market research, and then essentially build a product. This time around, we did something completely different, where we went out and did what we called customer-focused design sessions, or CFD. CFD is a business process that Microsoft is actually patenting that allows the voice of the customer to go into the very beginning stages of the planning session, so that instead of us thinking, well, we believe this is what customers need, we have actual real customer data. So this time around, we went out and literally flew around the world and visited a little over 200 customers, I believe. We sat down with them for an entire day, where we would bring in the CEO, the CFO, the CTO, their security people, the IT people, the desktop people. So we wanted a very diverse set of opinions, and we would go through this process. And they would give us information and answers, and we would go back and put it in a database and process it. And that's where our original vision memo or our documents came from. So Server 2012 was actually designed by not you people here in this room, but it was actually designed by customers. We went into this with no preconceived notions or thoughts. It was let's have the customers tell us what to do. It's been such a resounding success is that all Windows versions now will be developed with this framework moving forward. And other products are picking it up, like Exchange and Office and so forth. So in the TAP this time around, we have around 50 customers currently in production. There are about 150 that are participating in the program. And as you well know, for those of you that have participated, we do ask customers to run pre-production software in their production environments. So even prior to beta, when we had our first milestone release, so this is pre-beta software, we had roughly 50 customers that were deploying this in production. So it's a very tight partnership. Because we realize you have a business to run, and yet we're asking you to put pre-beta software in production and give us that feedback. So the feedback we've gotten has been tremendous, and you'll hear more about that later. But again, we wanted to focus on specific scenarios. So we did focus quite a bit on the cloud, of course, and then something that we call, or that by definition, is the hybrid cloud. Anybody have a notion what a hybrid cloud is? Okay. A hybrid cloud is essentially where you have some assets on your site in your data center and some assets sitting in a public provider, whether that's Azure or a public hosting provider, and then you have applications and scenarios that run between those. So what we did for this program, we created a project that we called Project On-Ramp, which was specifically designed around the hybrid cloud. So I'll go into more detail about that later, and that's actually what our demo is we're going to show you Hyper-V replication with a real live hoster based in London. So again, the scenarios, we did focus quite a bit on the hybrid cloud. We also focused a lot on the private cloud, which by definition is assets running in your data center. So you control everything. They're all within your building. And then we looked at PowerShell and automated setup. As we sit here, I'm sorry, if I go back a few months, most of you realize that the System Center schedule and the Windows schedule are not 100% aligned. So we just released System Center 2012, and you would think, okay, well, that works perfectly on Windows Server 2012, but unfortunately it doesn't. So we're not quite in alignment. So we had to focus on building cloud scenarios without Virtual Machine Manager, and that meant PowerShell from the ground up. So we did automation and VM creation, completely using command lines. And of course, as you well know, we've made tremendous investments in PowerShell in this release. So we did not have the benefit of Virtual Machine Manager, which is a great product, to do things in this tab. Yes, this gentleman agrees. All right. We can't all afford it. I can. I get it for free, so it's kind of cool. Yeah. So anyway, like I said, a lot of focus on PowerShell early on. Service Pack 1 for System Center will be available sometime in the future, and that will be the product that runs and supports Windows Server 2012. So specifically, some of the features that we really focused on, NIC teaming. If you know your history, NIC teaming has been a very troublesome and problematic solution for our customers. And the reason is that to do NIC teaming, and I assume everybody knows what NIC teaming is, you had to have a solution from the NIC vendor. So if you had Intel cards, you could only use an Intel solution. Or if you had Mellanox cards, you can only use a Mellanox solution. So what we did is we said, okay, let's bring this into the operating system so that you can mix and match cards from various NIC vendors, and we'll support it in the box. So NIC teaming by far has been the most popular feature in Server 2012. How many of you have done some testing or evaluation of Server 2012 today? Oh, you people that haven't raised your hands, you're missing out. So I assume that you've probably noticed some of these features here as well. So I'm going to quickly go through this. Bandwidth control using quality of service, or QoS. The movement today is moving away from 1 gigabyte networks to 10 gig networks. So now you have these very, very large pipes, and so the way that you actually isolate traffic is by utilizing technologies like QoS. So instead of putting everything through this big pipe, you want to be able to carve up individual pieces so that your CSV traffic goes and gets a certain amount of bandwidth, and your live migration traffic gets a certain amount of bandwidth. So we spent a lot of time on evaluating and generating QoS policies for those customers that are in a 10 gig network. Out of curiosity, how many customers are running in a 10 gig network? Smaller number, okay? And I imagine a lot of you that didn't raise your hand are either thinking about it or considering moving to that. It is an expensive move, but there's a lot of overall payback that you get from that. Data center bridging is another solution that works very well with QoS. Again, allows you to do bandwidth control at the switch level between the operating system and the switch. A technology not a lot of people know about, but is actually very, very cool, is single root input-output virtualization, or SRIOV. If you have an SRIOV capable NIC and an SRIOV capable BIOS, which a lot of the next-gen HP and Dell servers will have, SRIOV allows you essentially to bypass the hypervisor and talk directly to the NIC hardware. So by doing that, you reduce CPU and memory dramatically, and you get better throughput on the wire. So SRIOV cards are very inexpensive. I picked up 2 for about $100 each. Unfortunately, I have Dell servers in my lab, so I'm running SRIOV throughout my lab. So if you're concerned about memory and CPU utilization, it's a very inexpensive solution to help address those problems. Hyper-V over SMB, you probably are going to hear a lot or have heard a lot around our investments in SMB. One of the things that we realized early on when talking with enterprises and hosters is that your number one cost, and raise your hand if you agree with me, your number one cost is storage. Is that an accurate statement? Okay, that's the majority of the room. So what we've done is, and our attempt to do, is to come in and and basically commoditize your storage design and give you much less expensive options by utilizing SMB. So we've made a lot of investments in SMB in this release, and our customers are really seeing the benefit of that compared to an iSCSI or even a fiber channel solution. And Alan's going to go into details of our storage story later. Then, of course, storage migration. Now, in Server 2012, you can do migration of your virtual machines and migration of your storage completely separately, so that it allows you to do easier maintenance on your SAN. And again, you can disconnect the virtual machine and the storage. And then we had a special program that we did with Cisco around the Nexus 1000V, which has never been supported on Windows until this release. So essentially, we have a handful of customers that were validating the features of the 1000V, and we have a very, very tight partnership with Cisco around this as well. So one of the concepts, again, that has been unprecedented until this release was what we call Customer Zero. And Customer Zero is Microsoft. Meaning that if you know Microsoft, you know, to use the American phrase, we eat our own dog food, meaning that we are constantly running beta software in our production network. And so this time around, we utilized something called the Enterprise Engineering Center, or the EEC. Have any of you heard of the EEC? That's exactly what I expected. So the EEC is probably one of the best kept secrets at Microsoft. And what the EEC is, they're a part of our division, and they essentially have labs in Building 25 on campus. I mean, labs that are $50, $60 million investments, where if you go to your account manager and say, hey, we want to evaluate Server 2012, but we don't have all the hardware to do it, your account manager can contact the EEC. They ask you a few questions. You fill out a questionnaire, and the EEC will build out your environment for you as best as they can, and it's a free service. So all you would have to do is pay for your flights and hotel to Redmond. The EEC would give you a dedicated program manager, and by the time you arrived in Redmond, your entire environment will be built in front of you, so that you can now sit down, evaluate the software, and run through your scenarios. So if you're taking notes, write down EEC. It is a free service, and it is a fantastic service. Again, they have hardware from all different types of vendors. We have customers that come in from Japan, so we ship in gear from Hitachi and NEC. If you have special gear, we have partnerships with everyone, and we can bring that gear in. So now that you know what the EEC is, and they have these great labs, we utilize those labs to build out some very complex customer scenarios in the Customer Zero work. We have published some of the white papers and diagrams and so forth, which I won't go through this in detail, and I apologize for the people in the back. It's probably difficult to read. But these are some of the samples that we built out. So when you talk about the term private cloud, that's every person in the room has a different definition in their head. So for us, we looked at 3 types of clouds that we wanted to build. One was a very high-performance cloud that utilizes technologies like RDMA and SRIOV. One of them was a very mobile cloud. In other words, where you had virtual machines that were constantly moving across your data center, so it was very flexible. And then the third cloud was what we called the high ROI, or return on investment. So it was done very cheaply, using inexpensive storage, inexpensive hardware, and of course, you have trade-offs in that in terms of performance. But we basically built all these, documented everything that we found, and then gave you step-by-step instructions on how to do exactly the same thing. So again, the work is really kind of unprecedented, but customers are really going to see the benefit from it at the end. So as we move to the hybrid cloud scenario, there is lots of focus internally on the hybrid cloud scenario. And the reason is that as we sit here today, the cloud, whatever that is brand new, right? We're in very exciting times as computing is shifting from on-site to off-site. How many of you are taking advantage of a cloud service today? Okay, that's about half the room. I expected that. So by hybrid cloud, the reason why we have to focus on this is that we realize for the next 10, 20, 30 years, the hybrid cloud scenario will be there, whereas you have some virtual machines on site and some running somewhere else in a public provider, somebody that you pay or an untrusted entity. So until the day where everybody pushes everything to the cloud, which may or may not happen in my lifetime, I don't know, that hybrid scenario will be there. And so we spent a lot of time and really focused on that scenario so that we can get more coverage from the scenarios that we wanted to build. So the question first came is that, well, that's fantastic, but how do we really validate this? So if I go back and look at the TAP program, we had enterprise customers, medium and small business customers, and we had hosting providers all around the world, actually. And so what we did is we kind of, somebody called it a dating service, and so since I ran the program, I sort of matched these people up, and we called it Project On-Ramp. So we would take some customers that were already in the program and some hosting providers that were testing scenarios for us, and we would bring them together to validate certain hybrid cloud scenarios. It turns out there was we found a lot of great issues and got a lot of great feedback around this. There are some scenarios, like Hyper-V Replica, for instance. How many of you are familiar with Hyper-V Replica? Does everybody love Hyper-V Replica? Inbox free disaster recovery. It's cool, cool, cool. So one of the things that we realized is that some of these technologies, like Hyper-V Replica, were really not designed to work in a hybrid scenario. I'll give you a little background. Hyper-V Replica was designed to do intra-data center replication. So in other words, if you had an office in London and an office in Glasgow and you would replicate between them, well, those were your offices. You own them both. So there are a lot of very unique challenges that we had in terms of doing replica from my data center to a public hosting provider. So things like how do we handle multi-tenancy? How do we handle authentication? What types of credentials can be used? How can the service provider guarantee that nobody else has access to my VMs while they were there? How do I ensure that I can bring up the VM on the hosting side very easily without the hoster interacting or without me interacting? So when you think about disaster recovery, all of these scenarios and questions come to mind. So these were issues that we had to dive into and understand better. And again, some of the goals around this were to come up with documentation and best practices for our customers that are interested in doing these scenarios. So I talked about some of these, some of the challenges. How do we do authentication? How do we handle credentials? Again, the whole multi-tenancy and a guarantee of security by the hosting provider is probably the #1 problem that we had to address. And so early on, like as I mentioned, these scenarios just simply didn't work. It required many, many phone calls to the teams in India and the teams in Redmond and doing real-time design over the phone or over a link session to understand how can we get this to work in a public hosting provider. And so some of the challenges that we had, were around the actual authentication. So to do authentication with a public hoster, much like you do SSL authentication for the web, you have to use a certificate. Well, early on, the certificate requirements were very, very stringent. So in other words, you couldn't use a wildcarded certificate, or you couldn't, the certificates had to come from the same root authority. And in a hosting provider, that just is not a viable option. So when I went out to customers, to the hosting providers to build out these scenarios, these things just simply didn't work. So again, it was one of these processes where the TAP program got us the feedback in time so that we can make decisions around design literally in real time. And so within a matter of hours, in some cases, we would get a fix from a team in India or Redmond to make these scenarios work. So they were very, very challenging early on. So today, as you do Hyper-V Replica, as you do hybrid Hyper-V Replica, a lot of the steps are manual. And I'm going to walk through some of the manual steps in my demo here in a second, so that you'll see what you need to do to make this work. But at the same time, I'm also going to show you how easy it is once you've made an agreement with the hoster. So the hosters want this to be completely automated. They want you to go to their website, give in your name, give in the names of your servers, type in a credit card number, and then they'll basically provision you storage and the ability to VPN in and replicate your virtual machines over. Today, that's a manual process. As we move to RTM, we will make that an automated process via PowerShell. And so once you've provisioned the user for Hyper-V Replica, then you want to be able to manage that through the web. So that's another challenge that we're facing, is that, okay, I've replicated my virtual machine to the hoster, but now I want to bring it back. How do I do that without having to call the hoster? So that's what we're going to automate by the time we RTM, and System Center is also going to help with this quite a bit. And again, the biggest problem we probably faced is multi-tenancy. And it's not just with Hyper-V Replica. Multi-tenancy is a very difficult problem to solve. As a hosting provider, you have to provide a service level agreement to your customers that guarantees security, and yet the technologies that we use today with VLANs and various tagging and isolation technologies simply aren't good enough. So we have technologies that are coming in Server 2012, like Hyper-V Network Virtualization, that'll be supported in System Center that will help with this right now. But as I mentioned, System Center is still catching up. So the multi-tenancy scenario is basically each customer gets assigned a VLAN when they sign up, and that's how they do security. However, if you're familiar and know VLANs, they don't scale. In other words, your hardware may support only 2,000 to 3,000 VLANs. And in some of the meetings we had yesterday with hosters, that was their exact problem, is that I can't sign up new customers because I don't have any more VLAN capacity. So these are real issues that customers are working on. So with that, I am going to show you a demo of cross-site Hyper-V Replica. Can you see my server? Yes. Okay. All right. So my partner, the hosting provider, is a company called GCI. They are a large telco based in the UK. They have offices in both, all over Great Britain, essentially. And what they have done is they were part of Project OnRamp. So we went out on site with them, build out some of these scenarios. And so a few weeks ago, before TechEd North America, I emailed my friends over there and said, okay, I want to do a live demo on stage. So provision me for cross-site Hyper-V Replica. So I emailed him. And so what I got back are these two items. This is a notepad file that just essentially, and please don't steal my VPN credentials, has my VPN credentials. Here's the server, my username, my password, and then basically the DNS name of the replica server, which is HV whatever, CL1, etc. So what I've done is I've already provisioned my VPN client, so there's no reason to walk through showing you how to do that, because I'm sure you can all do that. So fortunately, the internet is working today at the show, so I just was able to VPN to my client over there. Now, the other thing they sent me is a machine certificate, okay? And again, this is the credential that we use to authenticate between my laptop that's running Server 2012 and their replica servers in England, okay? So essentially, all I have to do is double-click on it, and the import wizard comes up. So this is a machine certificate, so I select that. I'm going to put it right there, and I have this very secure password here that I just typed in, and I click Next. It says, do you want to do this automatically? I say, yes, it's a machine certificate. So basically now I hit Finish, and the import was successful. So if I go in here and I refresh, you'll see that I now have a machine certificate that was issued to me by GCI. Okay? anybody can follow those steps, right? Even an idiot like me. So I have a certificate. I have a VPN connection. So now I'm just going to go in here, and I am going to cut, make sure I get it all, the name of their replica cluster. And then I'm going to go into Hyper-V. So I have, I'm running Hyper-V locally. I have a VM that's here. And for those of you that have never set up Hyper-V Replica, I'm going to show you how simple it is. So I go to the virtual machine. I right-click. I say Enable Replication. It asks me for the server. Okay, well, I just cut that, so I paste it right here. And I hit Next. And now what Hyper-V Replica is doing is it's going off and querying the server on the other side to first of all see, okay, is this server enabled for replication, and are you permissioned on the other side to see some of the details? Now, you'll see the warning on the bottom. Let me zoom in here. Of course, I ruined the whole thing. So it says I can't get configuration details of the server. And the reason is that I'm not an admin on their server, okay? It shows me that it's set up for replication, but it's a security thing. So now, basically, it says you can replicate to this server, but I can't give you any more details about its configuration. If you were doing this within your data center and you were privileged enough to see the other side, well, then you would see more details about how their server is set up. Sorry, let me zoom out. Back into the wizard here. I apologize. Oop. All right. Well, let's just paste it again. Okay. So you'll see here as well, I can look at the certificate. That's the certificate that was issued to me. I'm just double checking to make sure it's the right one because I may have multiple certificates here. But if you can read it, it says GCI hosted. GCI is the name of the company, and that's my partner that I'm replicating with. So, okay, everything looks all right. So if I hit next, it says, okay, where's the VHD? This is the location of my VHD. It says, do you want to do just the latest recovery point? So Replica has a lot of options around what you can actually replicate. So since this is my first time, I'm going to select next, and I'm going to say, yes, send the whole VM over the network. So now when I hit finish, it's a big VM, sorry. This is an awkward pause. Oh, you kidding me? Okay. Let's start over. All right. So open it up, import my certificate. I want local machine. Yes, password. Import was successful. Go back to Hyper-V. Enable replication. Paste the server. Accept all the defaults. Yes, that happens when you're in the initial enabling phase, which is why I'm a little confused why we got the error in the first place. Oh, the question was, is the authentication validated before you actually do the attempt? And the answer is yes. The question was, if we were doing this via PowerShell, would we see more diagnostics? Probably not. The diagnostics are basically the same. So, all right. Anyway, I apologize. This worked in my tech check last night. So, anyway, that is essentially the steps that you go through to enable cross-site replication. I guarantee you, as soon as I walk away from this 30 seconds, it'll all work. But so. Again, the idea here is that if it worked, and it worked in America, so maybe it's just my luck, is that enabling cross-site replication. So if you're a hosting provider, hosters are very excited about this because they see this as a new business and a new revenue opportunity. And you as customers see this as a potential disaster recovery solution that's inexpensive and built into the box. So there's lots and lots of benefits to that. All right, so with that, I'm going to invite up my friend Damian Flynn from Lionbridge, and he's going to talk to you about his experience in the Server 2012 TAP.
Good morning, guys. Thank you, Pat and Alan, for inviting me to join you today on stage. I suppose I'll start with a little quick introduction of who am I and who are Lionbridge. I'm lucky enough to be an MVP for Microsoft with Cloud and Data Center Management, with focus over virtualization and private cloud. I also have been an author on a new book, which is Microsoft Private Cloud Computing, that was just released last week. And Pat's going to donate a copy of that to somebody lucky in the audience this afternoon. Lionbridge itself is a service provider. We are a partner with Microsoft for the last number of years. We offer a number of different types of services, including software localization, testing, and certification. So you'll have actually seen some of our work when you buy a product with the Certified for Windows logo on the front of the box. You're also been using our work if you happen to be using a localized version of Windows. And that's one of the reasons that working with Microsoft is very important to us, because our scale of work that we do in the back end spans the world. We have to take a product in and source language and convert it into one of 140 other target languages during the course. And for Windows 8, that's just one of our projects. And to do that, we need a lot of people and a lot of technology to make that happen. And working with the technologies that we have in Windows 2012 is enabling us to prepare for the next generations and scale that out as we continue bringing more people on site or sending more people to telework in to do the work with us. So why TAP? Well, obviously, we've got a lot of new technology coming in. It allows us to optimize and simplify our environment as we continue to do that scale out. And having the communication channels that we get directly into Alan and Pat and their colleagues in Microsoft, it allows us to start thinking about the scenarios that we want to build out as an organization, start aligning some of our strategic plans and thinking about how it is we're going to actually implement the next-gen technologies like 10 gig Ethernet, and start thinking about at the same time, what does that mean to us as an environment where we're virtualized and we're running private cloud, and also trying to continue to scale that without disrupting the existing technologies that we have in place today. So our plan of action in that scenario is taking that on-ramp process that Pat and Alan started with way back at what was known as the Futures Council. So 3 and 4 years ago, we spoke with these guys and told them what we're thinking of doing, how our business is changing, how we plan to scale out. And they come on site and helped us to understand their thoughts on what maybe Windows can do to help us. And together we've come out with a plan of action of what it is we want to do and how we're going to try and achieve that. And over the course of the last number of months and years, we've been working with the newer versions of Windows and start deploying it out, giving it a test, figuring out, oh, this is working, this is not working, and working our way through those different issues. And as we get closer then to a point in time, we started moving this into actual live production. And we had to make some decisions about how do we do that, what's important to us to actually take this environment and bring it into a live production scenario. And this includes addressing things like taking the environment we have today and maybe splitting in half, keeping part of it running on 2008 and taking the other part and moving it up into 2012, figuring out what type of workloads we're going to put on those so that we have a good idea as we get everything sorted into 2012, how is it going to work and behave, and take advantage of that communication channel we have with Microsoft. So putting non-Windows operating systems into virtualization, taking our business line of apps, our Exchange, our Link, and our own internal apps, and basically then working out those issues, the kinks and the problems. And we've had scenarios where Microsoft guys have actually come physically on site, hooked up debuggers into the back of our machines, and gone through all sorts of magic to figure out why things aren't working and fix issues for us and get us to that point where we can start turning around and saying, okay, we're stable enough to actually move from maybe a small pilot of 2 or 3 machines and start adding more machines into the cluster and start scaling those out as far as those 16 and larger size clusters. At the same time, we also took the jump into thinking about new networking technologies, updating our core infrastructure that we have in our main data centers and putting in things like Cisco Nexus, thinking converged networks, looking at the technologies that we get in Windows 2012, the stuff that Hyper-V is offering, that extensible switch, that Nexus 1000V stuff that Pat has talked about, and figuring out how is that going to work for us? How do we plug that in, make that coexist with our live environment? So the communication channels that we get between ourselves and with Microsoft as we go through these internally, put in the environment, put it through different tests, go back as far as Cisco and say, look, we've got a problem with routing or whatever the case may be, or go back as far as Microsoft and say, this works, but this piece doesn't. Can we figure out what's going on? And together we get builds and fix issues and get to a point where this stuff becomes rock solid and we get to that stage where we say, yeah, this stuff works and it works very well and our scale becomes much better. So that's really one of the major benefits and reasonings for us to continue doing that type of work with Microsoft, in that we get those issues sorted early in the product life cycle and figure out how to actually make this stuff scale and work in good scenarios. So with that in place, then we've simplified the world, because with all the changes that's going on, we also want to keep the minds of our engineers kind of less complicated as we can. And we go back and look at the hardware that we have in the data center, what we're reusing, how can we simplify that. And we look at the fact that most of our Hyper-V servers today probably have 8, 10, 12 network ports in the back of them, segregating different networks and different VLANs for live migration and all that sort of carry on. And there's lots of little bits and pieces that have to be set up right across the clusters to make sure everything works well. And then when we go to the 2012 world, we can run a PowerShell script and it just does it. We don't need to spend that same amount of time configuring, tweaking and modifying. We can turn on things like QoS now, where we can turn around and say, yeah, live migration is actually important. We can put in pipes of multiple 10 gigs, so we can have maybe those 10 Ethernet ports sitting in the back of the machine, all of those 10 gigs, so you get to imagine you get a pretty big pipe very quickly. And then you can turn on QoS and figure out that live migration is actually very important to me, or no, it's not. SCSI is. And I can make small changes without having to go back in and start putting cables and rerouting or making changes on the network. I can simply issue one PowerShell command to say, change the quality service that I'm allowing on my SCSI, and all of a sudden I've got more bandwidth. So these sort of things allow us to tweak that environment and start figuring out how it is we want it to run as we get closer into the live productions and we start scaling in the rest of the environment that we haven't yet moved over. So out of all of this, we've obviously had some days where we felt like we're sitting in the frying pan, and other times where we feel like we're sitting out in the sun. The one thing that's probably hurt the most is probably the fact that there is a deviation between what we have from the operating system versus the management tools. We're trying to run this as a private cloud in many scenarios. And in all due respects, when 2012 is so far ahead of what we have in System Center, that's not feasibly possible for us. We can't do that private cloud front end. So that's where we make that decision to basically keep some of that stuff in 2008, and then the stuff that we know that we can manage as an infrastructure team without having to do the private cloud stuff, that's what we segregated over and focused on in 2012. The fact of the point was that was actually our business production stuff. So we think of our line of business apps or Exchange or Link. So the risk levels in one scenario is kind of high, but knowing the relationship we have with Microsoft and knowing that if this stuff goes down, we have a phone call away from ringing Pat or Alan, and we're going to have an engineer on site if needed very rapidly. On most of the time, it wasn't even needed, to be honest. They can walk you through some scenarios and we can get back online without too much pain. And of course, we build our stuff to be resilient, knowing the fact that we are putting our eggs in a basket that we don't know if it's got holes in it or not. So that allows us to go through those scenarios. The other piece of point is that Pat and his team have certainly put together a fantastic set of PowerShell scripts, and some of those are available already publicly, for migrating stuff out of 2008 over into 2012. They work, and they work very well. The first one or two of them obviously is going to be that learning curve as you go through it, but we certainly embrace the fact that VMM 2012 with Service Pack 1 is going to make that life drag and drop for us. So that's certainly going to be something we're going to look forward to as we move into taking the rest of the environment over into the full production. And then as we move away from that and know that we've built out our infrastructure based on this brand new technology, got that fantastic 10 gig core in place, we can then start taking a look at what it is that we get with things like the Hyper-V virtual networking services, the extensible switches, and all of that stuff that is really valuable to us in our private cloud, and spend a little bit more time with Virtual Machine Manager to understand how it's going to embrace that and move us forward. So all in all, it's been a really, really good experience, and certainly something that if you haven't tried Windows 2012 for, we can only suggest that you go do that as soon as you go home. So with that, I just want to say thank you to Alan and Pat for support that they've provided us so far on Windows 2012, and good luck with the launch.
Okay, good. I'm Alan Stewart, so I'm the GPM of the customer engineering team, and I'm responsible for all the testing of new Windows Server releases. Just a brief history of my background. I've been with Microsoft for about 13 years. 7 years ago, I ran the first engineering programs for Virtual Server. Anybody remember Virtual Server? Fantastic virtualization release from Microsoft that satisfied everybody's needs, right? Not necessarily, right? So what I'm going to talk about is some of the areas that you now have to think about as architects when you're architecting a private cloud solution using Windows Server 2012. There's some disruptive areas, and there's just some things that we did that were kind of disruptive in the storage and networking area. As previous programs or previous releases of Windows Server, you really didn't have to think about. So when you think about Windows Server 2008 R2, you didn't have to think a lot about your storage options, right? If you were going to be doing live migration or quick migration from SCVMM, you had to have a block-based SAN. There was no other option. You were going to use Fibre Channel or iSCSI. If you were going to create virtual machines, SQL virtual machines, and cluster them, you had no choice but to use iSCSI. Now in the storage arena, there is a ton of choice. And there's a lot of things you actually need to start to think about. There's some new technologies that you need to think about. RDMA. How many people here have a lot of experience deploying RDMA-based solutions? No? And where I got my experience was working on Wall Street, working on banking applications where applications are latency sensitive, so RDMA was widely deployed. Now RDMA is actually a storage option for you. It's a storage medium you need to think about. When you start to look at some of the Hyper-V over SMB technologies, the first thing when you talk to a storage architect is, we don't want to use that, it's too slow. RDMA actually bridges the gap between making a locally attached disk or remote share look and perform like a locally attached disk. So there's a ton of new options, right? So let's jump into some of them. So early engineering customers are really still kind of working through some of the storage options, all right? Do I stay on iSCSI and Fibre Channel? All right, I've made investments. All right, I always hear this a lot from storage architects. Are you telling me to get rid of my $25 million block-based SAN from X vendor? No, I'm not saying that. I'm saying now you have different options. So if you start to look at even deploying a VDI solution where a lot of the Hyper-V over SMB deployments are coming into play because the ROI is kind of shaky in the VDI space, so you don't want to deploy high-end storage. So Hyper-V over SMB looks attractive. You don't have to throw out anything. This is now just a new option that you as architects have to think about. Do I want to deploy, or am I moving towards commodity storage? And do I want to look at file-based solutions? Right? When do I use Hyper-V over SMB? So this comes up. Do I use it for specific scenarios like VDI, where performance may not be as critical as deploying in my big private cloud environment? And the answer is, we expect you to use it in any scenario. But when you're thinking about architecting a high-performance storage platform, some of the other technologies around it, like RDMA or SMB multi-channel, are things that you really need to start to think about. And the technology that I mentioned around RDMA is called SMB Direct. So when you start to, I'm going to build out a private cloud environment with file-based storage, RDMA should be one of the options you look at. And I know there's a history in RDMA when you think about InfiniBand. Wow, okay, that brings along specific cards, that brings along specific InfiniBand switches, but there's new technologies around RDMA like Rocky, RDMA over Ethernet. So you don't have to have specialized devices. If your card is RDMA capable, you can use this over the Ethernet storage medium. So now, Ethernet medium, so now it offers a lot more options to you, okay? Scale out file server. So if you are building out a private cloud environment, you most likely are not going to have one file server serving out your 64-node cluster, your Hyper-V cluster. So this brings into, now I need to cluster the file storage medium. There we have the technology called scale-out file server. There you get options like transparent failover. Right? Hey, how many people here know about transparent failover? Very few. It's very important because in transparent failover, you can actually, at the protocol level, you have the ability, if you're running, say, SQL inside of a virtual machine, if you're using a scale-out file server as the backend for your Hyper-V environment, at the protocol layer, if your connection goes down, we will actually, instead of failing over the cluster, we will fail over the channel at the SMB level. So your SQL cluster will just see a brief blip, or your SQL virtual machine, and you continue to run without having to take a failover. When you fail over, you get into various timing issues. QSing your machine, this happens transparently, particularly if you're running an SMB file server. So this is another important thing that you need to start to think about on the scale-out file server. If you're going to be deploying file-based storage for your Hyper-V cloud, you need to look at scale-out file clusters, because that is going to be the back-end storage and how you protect your storage for your private cloud environment. Okay? And while there's a ton of new technologies in the box, you need to decide what is your storage direction moving forward. Are you going to stay on block-based storage? Or are you going to investigate file-based storage? You probably hear a lot from a lot of product engineering and storage, this whole idea of commodity. Commodity storage. We heard this a lot from hosters. We want to move into the commodity storage space. As Pat mentioned before, storage is a large cost in your environment. File-based storage gives you an option to be able to run on commodity storage entities. But there's a lot of planning that goes along with that, right? We're not trying to necessarily change your storage direction. We're trying to disrupt your storage direction with additional options. Okay, so we kind of talked about this. I'm just going to get into it because it's always a good refresher to kind of give you an idea of what I mean when I'm talking about your different choices. So now you have the capability of storing application-level data, SQL data, Hyper-V virtual machines on a UNC path on a file server. Now this is a first-class storage option for you when you decide to build your storage options out for your private cloud environment. SQL 2012 actually allows you to run databases over SMB. So I want you to think about that option. Before, if you were going to run SQL virtual machines and cluster them, the only capability you had to do that was using iSCSI within the guest. Now, if you're running SQL Server 2012, you can actually provide clusters over SMB shares from within the virtual machine. Or, if you're still running Fiber Channel, many of you know we have a synthetic Fiber Channel adapter inside the virtual machine. So now you can actually connect your virtual machine to your Fiber Channel SAN and have it participate and cluster within the virtual machine. So just alone, those few options, now you have additional things that you can actually do. Whereas before, you were only limited to one option if you wanted to cluster virtual machines. So this was the strategic direction for us to enable file-based storage for application workloads. One of those applications is Hyper-V. Another application is something like SQL Server. And don't ask me about Exchange. You can come up later and we can have a conversation about that. Exchange moved readily forward about 3-4 years ago in supporting the DAS-based storage paradigm. Hyper-V, SQL Server are just coming around to this type of paradigm, right? Okay, the SMB scale-out server. This is important to mention because if you do decide to go down a Hyper-V over SMB path, a file-based access path for your private cloud, you will deploy an SMB scale-out server because you have to now protect the storage part of your private cloud architecture. With SMB fail-out, it allows you to have, with the scale-out file server, now you can have active-active, shares being run off multiple nodes in the file server cluster. You get transparent failover. The only way you get SMB transparent failover is when you deploy an SMB scale-out file server. So if you just had a single file server running Hyper-V instances over it, you would not get that transparent failover. You only get that when you deploy a scale-out file cluster. So if you do decide to go down the file-based path, you will be deploying an SMB scale-out file server protecting the storage medium, right? Okay. Now my favorite technology, all right, because I have a lot of history with RDMA, is what we call SMB Direct, or running SMB over RDMA. And what are the two main reasons why you want to do this? One, you gain latency improvements by running RDMA, but you also gain CPU time on the Hyper-V host and on the file server host. If you don't use RDMA to offload CPU interrupts on the file server, you wind up taking up CPU time from the file server or from the Hyper-V server itself. This offloads that CPU interrupt processing for file serving onto the cards itself. So it reduces the CPU overhead on a system. So when you see these numbers around 9,000, 1 million IOPS per second, all of those are using RDMA and offloading. Because to run 1 million IOPS would require probably about 50 to 60% of the CPU on a host to be able to do. This offloads that capability onto the RDMA cards and provides you that enhance pipe, but also provide you reduced CPU utilization on the host. So in box, we support RDMA by default. So if you had an RDMA capable NIC, there's not a lot of knobs you need to actually turn this on, right? So there's a quick PowerShell script, RDMA equals true, and from there we can actually start to use RDMA. When you start to architect this solution, you need to really think about the interconnects from your Hyper-V server to your back-end storage. Whether you're going to use InfiniBand, which I mentioned before requires specific hardware, or whether you're going to use RDMA over Ethernet, or as we effectively call Rocky as the alias for it. All right, so you have a bunch of different options, and when you see high performance over SMB, most likely is being demonstrated via RDMA. Now, what does that mean from a numbers perspective? Okay, I kind of mentioned before, one of the objections, if you will, from a lot of storage-related folks are, you know, file-based storage is interesting. Yes, it's cheap, it's commodity, but it doesn't perform as well as Fibre Channel. Okay, so the purpose of SMB Direct is kind of debunk those claims. All right, so I mentioned before, one of the test criteria for RDMA was RDMA would perform about 90 to 95% performance of a direct attached disk in a server using a remote file share. So if you look at these numbers, this was done with InfiniBand. So you have a locally attached disk giving you about 11,200 megs per second, and you have a remote file share coming really close to that type of performance. So a disk running in a server gives you obviously high-end throughput, but a remote file share running over RDMA gets really close to that same type of performance. So think about the flexibility where now you've disconnected the storage and you're able to run over file base. So this gives you an enhanced level of performance and the confidence to be able to run file-based storage for your private cloud environment. Okay? And this shows some additional capabilities where the difference between a local performance is anywhere from about 350 meg per second of a remote file share. So now this really starts to give you some options. And if you talk to some of your storage folks and you say, I want to do file-based storage in Windows, and they say, well, it's too slow. It won't work. You can start to show some of these numbers. Okay. Moving on from storage onto networking. So one of the things that we've been doing over the last 7 years of Microsoft virtualization is scaring you to death around isolating traffic and hosts. Right? So if you look at the Windows Server 2008 R2 recommendations, we recommend that, one, you have a NIC for CSV, you have a NIC for live migration, you have a NIC for the host, you have a NIC for the virtual machines, and then you have a NIC for if you're running file-based storage. iSCSI as well. That's a lot of NICs, right? When we looked at designing the hosted cloud scenario for Windows Server 2012, we talked to a bunch of the OEMs and said, what will the world look like in servers? They said, well, probably have 2 10 gig NICs in the server. Okay. So that's the world we need to design for. 2 10 gig NICs in a server and not having you to run multiple network adapters just to isolate traffic. So Pat mentioned QoS and bandwidth control. Part of that was enabling QoS on the system. So instead of scaring you to death around putting multiple network adapters in a server, now we tell you, you know what? Forget everything we said. Don't do that anymore. If you have 2 10 gig network adapters, run all your traffic over it. And, you know, to my surprise, that's probably been more scary for customers. They were like, well, Alan, I've been listening to you for 5 years, telling me isolate everything, and now you say don't do any of that. It's just magic now. With QoS, we'll balance all of the traffic, just run it over 2 10 gig NICs. And I'll tell you that some customers, even when they deployed Windows Server 2012 in production, all isolated traffic. And when I ask, why are you doing that? They're like, yeah, I heard you, but, you know, I'm more comfortable going down this path. Right? So this just talks about some of the same things that I just mentioned. The but is this, okay? In those different configurations, so in customer zero work, I think Pat explained it to you, but I really want to lay it out. So since I've been involved with every single engineering program around Microsoft virtualization, this time around, we built configurations. And we said we are going to test the configuration end to end We're going to do it with PowerShell. We're going to find all the issues in setting it up before you find the issues, even in the tap, which we started really early this go around. And we're going to publish all the PowerShell and the documentation at beta. How many people here know when you normally get Microsoft documentation? Do you normally get it at beta? Do you normally get it at RTM? You probably get it around 6 months after RTM, right? This time around, we actually have complete PowerShell scripts that show you how to deploy these configurations end to end. And a lot of work went into this. From my team, from the Windows Server engineering team, even the UX team who does documentation, documenting this and putting it out up on TechNet for you to use. So one of the things from a networking perspective, we looked and said, okay, the world is 2 10-gig Ethernet adapters and a server, but we know, if you look at the middle configuration, we know everyone is not running 10-gig Ethernet. Some people are still running 1-gig Ethernet. So that recommendation around leveraging QoS and 2 10-gig Ethernet adapters that are teamed works really well when you're running 10-gig Ethernet. It does not work so well when you only have 1-gig Ethernet. In the 1-gig Ethernet, you still need to have isolated traffic because you do not have enough bandwidth to run everything, live migration, CSV, host, file-based access over 2 10-gig Ethernet adapters that are connected to a 1-gig backend. There's not enough bandwidth. So if you look at the middle configuration, we still give you recommendations on being able to separate traffic when you're running 1 gig. If you're running 10 gig, if you look at the two outside, the left and the right, when you're running 10 gig, there's only 2 network adapters. We configure QoS, and QoS balances the traffic between the network adapters. And I will tell you, like I mentioned before, the fact that we now have quality of service to only recommend 10 gig Ethernet adapters has been a learning curve for a lot of customers, even when they're running 10 gig. It's this trust factor. We did a really good job scaring people to death and looking at a configuration and saying, well, you don't have isolated NICs. That's the problem in your configuration. Fix that, and then everything will get faster. So moving forward, this is something, again, from a design perspective, you need to start to think about. So you may see some recommendations around all you need is 2 network adapters. That is specifically focused if you're running 10 gig backends and 10 gig networks. If you're not, you still need to isolate traffic. Okay, so what are some of the other things that we've learned from the TAP? So we always start out with a perfect server release. We give it to customers, and then we find out how imperfect it is. Right? So I live in the imperfect. What's the problems? Problems, problems, problems. When I come to the show, it's like, wow, this is really great, really great. And I'm still thinking, okay, there's a few problems. Some of the things that customers wanted from us was this notion of being able to deploy in a work group. There's a ton of private cloud technologies at Microsoft, like clusters, System Center, that bring along an Active Directory dependency with it. But there are some scenarios like deploying inside of a DMZ. And file-based access kind of exacerbates this, right? So if you're deploying file-based access on a file share, we are tied, again, that process has been tied to Active Directory. So we had a lot of customers that said, you know, I'd rather just want to deploy in a work group. Say I'm in a DMZ, and I don't want to add Active Directory into the DMZ. I just want to deploy a cluster, connect it to an SMB file share, and I want to run it in workgroup mode. So that scenario is pretty challenged today because we take a lot of dependencies on Active Directory for a lot of different functionality. And this is something that we heard clear from customers to the point that we actually prototyped some Hyper-V over SMB, not clusters, but if you will, but farms of Hyper-V servers connected to SMB file shares in a workgroup mode, right? It's unclear moving forward on whether we're going to support that at RTM. It was possible. We prototyped it. We understand the scenario around it, right? Particularly in DMZ spaces where you don't want to deploy Active Directory or take dependencies on having AD, all right? So setup and management. So I spent the first 5 years of my career as a Unix system programmer, so command line is very comfortable. And I don't necessarily, unfortunately, people have told me I don't necessarily have a whole lot of empathy for server core and the learning curve that it takes to learn in server core, right? So look, yesterday I spent time with MVP, so now I'm gaining a new sense of empathy for you, right? Looking at the PowerShell command prompt in a server core instance could be pretty intimidating if you don't spend a lot of time in that environment. So How many people here know the default UI for Windows Server 2012 is PowerShell and Server Core? The others, either you don't believe it or you don't want to use it. It is the default UI, right? So, when we hear, well, why do we have the Metro UI on server? I said, there's a UI on server? I didn't know. Server Core is the default instance, but there's a lot of different things that you need to learn to get up to speed. When you just look at the PowerShell command prompt and say, now I want you to build a private cloud, that could be a pretty intimidating process moving forward, right? How many people agree? All right, there's more hands now, right? So one of the things, even from the customer zero, the specific project was to publish PowerShell scripts. The fact that we didn't have SCVMM at the time was more of a blessing than a curse. It forced us to build PowerShell, and it forced us to publish PowerShell for you to be able to use it from a starting point. I'd like to think that if we didn't have SCVMM, we would have did the same thing, but I'm not so sure. When there's time pressure, maybe, well, VMM takes care of everything. We'll just do it from there, right? All right, so one thing that we heard is no scenario. I've been hearing this for the last 5 years running virtualization programs. The scenario for virtualization not complete until SCVMM is available, right? Even though you can do stuff without VMM, it offers a ton of value adds. Even the scenario that Pat talked about, the on-ramp project, a lot of that stuff can be automated via VMM and PowerShell commandlets, and then you get the right sizing, the chargeback, the billing, the management, single view, single console view. So we realize that is critical. And as we move forward in programs, you'll start to see more of a synchronization between Windows Server releases and System Center releases. Okay? And documentation and samples, I don't want to beat this to death, but this is something that we will be doing from now on for every Windows Server release. At beta, publishing end-to-end PowerShell scripts and specific tested configurations for you to use, so you don't need to start from scratch. You can start from examples of how to go about building out these solutions when there is no real, Uber documentation or maybe even management products available for you. Okay, so what's next? Continue to publish some lessons learned as we move from beta to RC. And finally, we're at RC. Ship this thing. Finish so we can start working on the next release. And now the folks in the room that didn't get involved in early engineering programs give you an opportunity now to participate in early engineering programs, right? So there's two sides of it. We test, we get feedback, but the benefit for you is you're early. You're early, you learn, you know about this stuff. So by the time you get to a conference like this, if you've been a TAP customer, you're like, okay, yep, really good, know all about it, deploy it, use it, love it, even know some of the problems involved, even know some of the things that I talked about around storage, you'll know all the different architectural decisions you need to make when you actually go to architect a solution. There's always how a feature works and what you need to do in your environment to make something work and architect it. Okay? With that said, we have about 12 minutes for questions. I want to open it up to the floor. Thanks for your participation if you did participate in TAP programs, and you should remember my face and name if you do want to participate in new engineering releases moving forward. Thank you.
Can you turn me back on? So, first of all, for the record, I have discovered what is wrong with my demo. The certificate authority at GCI is unreachable, so the certificate revocation list can't be found. So I will be sending my bar tab to them tonight, and they can cover me. But
when in doubt, blame it on the cloud.
Exactly. The cloud's broken, so I can't do anything. So Damien caught me off guard and said we're giving away a book. I didn't know this, so both my demo failed and Damien blindsided me. So I don't know how I'm going to give away one book to a room of 70 people. So I've been thinking about this. So the first answer I hear correct, who knows the name of the stadium where the Seattle Mariners play? Jesus. It's a tough one. I know the audience. The Kingdom was torn down 10 years ago, but that's about as close as we're going to get. Because I don't have another question. So anyway, we'll figure this out. But if you have questions, let's open it up. If you have anything, or if you'd like to talk to us in private, we can close it down. So,
any questions?
Anything? Don't be shy. Yes, sir.
If you want to start over with new thing here, if you want to start in the bottom for NICs that are RDMA compatible, or where do you start when you will build your new data center today?
So the question was, if you're building a new data center, if you're starting from scratch, does it make sense to look at technologies like RDMA? The answer to that is absolutely yes. The cost and the benefit that you get, the cost of an RDMA NIC is, again, very inexpensive. And especially, as Alan pointed out, if you're going to go down the SMB storage path, it almost seems to be a one-to-one requirement. It'd be foolish not to invest in RDMA if you're going to.
We published the RDMA-capable NICs up on TechNet.
Yes. Yeah. Yes, sir.
Would you be able to boot on SMB direct or distance operator?
I'm sorry, could you repeat?
Can you boot on SMB direct or distance operator?
Oh, the question was, can you boot from SMB-based storage using SMB Direct? Yeah. No.
No.
Right? Yeah.
No.
Now,
I know the scenarios around you want to have diskless systems, right? Like boot from SAN over from boot from SMB. Not today. Not today. You can't.
Yeah.
We did introduce an iSCSI target at Windows Server 2012, and one of their scenarios was boot from iSCSI, but not over RDMA today.
Yeah. Good question. All right. Anyone else? Yes, sir.
So just to be 100% sure. So Alan, you were saying that if I'm thinking file-based rather than block-based, got into RDMA.
I'm thinking to get over the objections that we saw from storage teams and to get near performance of a local disk for remote share, RDMA is a really good option. If you're not going to be doing RDMA and you're going to be doing 10 gig Ethernet, I'd say you have some opportunity there. 10 gig. When you start getting in, I want to run storage over 1 gig, you start to run into contention problems, convergence, or you're going to have a separate network. With RDMA gives you really good. And if you look at Rocky, you don't have to deploy InfiniBand switches, which is, that was always InfiniBand's
cheaper
downfall. Now you can run it over 10 gig Ethernet. That gives you a ton of options.
The file services guys have demos in their booth down there that show actually some of the numbers that Alan highlighted.
And if you go to if you go down to the file service booth, they have a system called a cluster in a box, right? That's in-box SAS, but then they also show you using SSDs and RDMA systems as well. The performance is very good.
The demo that they're showing, they're actually moving the entire capacity of a DVD per second. It's phenomenal. Yes, RDMA is almost a must-have.
So one thing that I'm working on is education for IT pros around RDMA. I brought it up to say, hey, there's probably not a lot of knowledge in the Windows IT pro community around RDMA, and the GM of storage agreed, and he says, you have a knowledge, you will lead the working group for how do we educate IT pros. So I opened my mouth and I got a job. So
it's dangerous at Microsoft.
You'll start to see some guidance, what is RDMA, how does it work, to kind of demystify it, if you will. So.
Any other questions? Okay, well, we'll be here for a few minutes if you'd like to come up and talk. Please fill out an evaluation so that we can eat lunch. If you don't fill out an evaluation, we're not allowed to eat. So thank you very much for your time.